Okay, so today we're going to be talking about our sea ice climatology exercise. And I've got RStudio open here, and I got my 4 window panes here. I got my script editor, my console, my global environment where my objects should be stored, and my plots. So what we're going to do today is through this video, I'm going to write some code to help you guys get some sea ice climatology data, and you guys will follow along right here in the script editor right here. So first what we're going to do is just write a couple notes to ourselves here. This is going to be our sea ice climatology exercise. Okay, remember when we put these hashtags or pound signs in here, this is a note to ourselves or a note, and this is something that the computer will ignore when it sees just one hashtag sign. Well, we are going to be getting our data from a particular place. It is from https:// the National Snow and Ice Data Center.org. And that's where we're going to be getting our sea ice index and our sea ice area data from, and I've got that right over here. So this is what it looks like. This is the National Snow and Ice Data Center. We can, right down here, they got a series of data sets that we can look at. One of them here is sea ice. Let's go ahead and look at that. We're going to be looking at the sea ice index, which is the first one that pops up. This tells you a little bit about the data set. This is sea ice index version 2, and it provides a quick look at the Arctic and Antarctic-wide changes in sea ice, and it's a source for consistent, up-to-date sea ice extent and concentrations. This data is a 30-year, well, started in 1978 to present. So, and then it's got a 30-year reference period from 1981 to 2010. So you can look down here and see some overviews, the spatial coverages, the spatial resolution, the temporal coverage, and so on and so forth, what sensors are being used, and what the data formats are. But overall, what we want to do is actually get the data. So we're going to go ahead and go to download here. It's going to bring up a little box that says how to download data. We're going to be downloading data via FTP, which stands for File Transfer Protocol. We'll go ahead and click on FTP. This is when we get to the user form registration page. They would like you to, you don't have to, put in your name, last name, organization, email, all these things, project title, what it's going to be used for. You don't have to do it because you can bypass the optional registration, but it might be fun for them to see who you are. We'll just bypass. And then this brings us to the FTP site. And you'll notice up here in the browser, this says FTP here. That stands for File Transfer Protocol. And the way this is arranged is, number one, we've got a README file that we can click on, just a text file, and it tells you how to access the data. And we recommend that you read the complete documentation before working, and you can do that. We can identify ourselves as sea ice, as a user of sea ice index, and that goes back to that registration page. So we have north and south, and north is of course the Arctic, and south is of course the Antarctic. And if we click on this, we see that we can get data daily or monthly. We're going to go ahead and look at the daily data. And we have the option of looking at data or images. We're going to click on the data, and then we're going to see 2 files here that we're going to be using. We're going to be, here's one that with the word climatology inside. We're going to be using that one first. So this is the North Sea Ice Extent Climatology 1981 to 2010 version 2.1.csv. And so if we click on that, it actually brings us to a data set where we have, these are the standard years that the climatology is computed, and then here's day of year from 1, 2, 3, 4, 5, all the way down. If we go scroll all the way down to the bottom, 366 for even for leap years. And then we have the average extent, that's standard deviation, and the different quantiles, the 10th, 25th, 50th, 75th and 90th, but we're not going to be using those. We're going to be looking at average extent. So this is where we're going to get the data from, and what I'm going to do is just copy this here in from my FTP browser and just paste it here. This is where we're going to get our Arctic sea ice data. Put that there for us, and then of course we're going to also get our Antarctic sea ice data. And if we go back to our browser, and you'll see here that we can just hit the back button, and one more time until we get to south. We'll click on south, go to the daily data, click on data, and here is that climatology data now for the southern hemisphere, which is Antarctica. Same format. We're going to grab this and we're going to put this right here. Okay, so now we have a note to ourselves here about what our sea ice climatology exercise. This is the website we're going to. These are going to be our data sources. And so we are going to use, we're going to create an object called arc underscore clim, and this is going to be this is going to be an object that we create, and we are going to use the function read.csv, which is going to be the function that we use to read in this online CSV file. And so if I type help read.csv, you'll see that it's a data input function, and it gives what the usage is. This is here's read.csv. Do we have a header on this file or not? What's the separator? So on and so forth. Also, what's important here is an argument called skip, because if you'll notice something here on these data files, the first line here is not actual data. It's something else. So we might skip that line when we read it in. Okay, so how is this going to work? We're going to read.csv our Arctic data set, which is this one right here. We're just going to copy and paste this FTP site, so it's going to go out to the internet. I'm going to put it in quotes here. And get this data set. And we do have a header. So a header equals true. And all that means is that we've got a header here, day of year, average extent. We want R to know that there's going to be a header here. And we're going to use the argument skip, which is just skip the first line. Now we have a piece of code that we can run. Go ahead and run it. And there we go. So you'll notice up here we have something called arc.clim. That's 366 observations of 8 variables. And in fact, you can click on the table here and you can see it. Here's day of year, average extent, standard deviation, so on and so forth. And that is looking really similar to what we have here on this file. So we have read it into R, which is great. Okay, we can close that. So we can also look at the dimensions we want. We can write a code here, look at the dimensions of arc CLM. We run this. We get 366 by 8, which is the same as the 366 observations by 8 variables, so that's good. And we can take a look at the top part of it using a function called head. So it's going to look at the first 6 lines. And this is what they are. So here's day of year, average extent, standard deviation, then the different quantiles, and that's all fine because this is very similar or exactly what we have here. Okay. Oh, this is the southern one, so what I'll do is I'll just to make sure. Here's the north daily data. Yeah, so here's one, extent 13.778, yep, 13.842, yep, all there. Okay, all right, Now, day of year might be something that's a little bit new to you guys, but this is just a note for you here. So if you want to see a day of year calendar, that is going to be at http eis.sci.nasa.gov. So, HTTP disk sci. Okay, let's see if this works. Yeah, okay, so this is the Goddard Earth and Science Data Information Services Center, and here is a Julian day or perpetual calendar, and it tells you here's January 1, 2, 3, and it tells you what day of year it is. So here's January 1, January 2, that's day 1, 2, 3. So February 1 is day 32, February 3 is day 34. You know, day 299 here is October 26th. So it's just a way for looking at the years, and same thing here for leap year here. So going to 366. You can always see what day of the year it is. Okay, so that's day of year. Okay, so what are we going to do here? Let's go ahead and try and now read in our Antarctic data. antclim read.csv, and we're going to put our FTP Antarctic data in here, in these quotes. Good. And it's going to be header equals true and skip equals 1. And so we should go ahead and read that in. All right, we have our Antarctic data set now, so that's good. We can look at the head of our, and there it is. Okay. And now let's see what we can do for plotting. So let's go ahead and plot only the Arctic sea ice extent. Okay, so this is going to be our XY plotting like we did in our last tutorial. Again, let's take a look at plot. And we need X and a Y, and in this case our X values are going to be time or year. I'm sorry, it's going to be day of year, and our Y values are going to be average extent. So let's go ahead and define that. So we're going to do plot where X is going to be equal to ArcClim column 1, all rows one first column. So if we look at the head of ArcClim, there it is. Here's the first column, and let's just go ArcClim. We'll do all columns first, all rows first column. There it is. There's the line of numbers from 1 to 366. So that's going to be our X variable. Our Y variable is going to be ArcClim, all rows, second column. That's going to be in our extent. Remember, let me see, take a look at that again. ArcClim. Yeah, so here's our average extent, day of year and average extent. Okay, so that's going to be our Y variable. So let's go ahead and plot that up. Let's see what we got here. Okay, so we made a plot showing on the y-axis the day of year. I'm sorry, the y-axis is going to be the Arctic sea ice extent, and on the x-axis is going to be day of year, but this plot is missing a few things. Let's go ahead and make it look nice. Let's go ahead and add in here a nice point character. So PCH equals 20. That tells it to be a solid filled-in circle, but you could do PCH equal 1 or 15. So that's solid circles. If you want to see what something else looks like, we can do, I don't know, PCH equals 4. And what do we get there? We get, X's. But we're going to go ahead and stick with solid circles, which is 20. All right. Good. And what do we need next? Well, we need an X label. So our X lab is going to be, in quotes here, day of year. Okay, that's good. So if we run this, yep, day of year. There it is. Okay. And our Y lab is going to equal average Arctic sea ice extent. Okay, how are we doing here so far? Let's go ahead and run this line again. All right, good. And now what we're going to do is add a argument called main. And what main is going to give it's going to give us a nice title up here. So we're going to call this sea ice extent, and this is in millions of square kilometers. Okay. So there we go. Okay, so on average, this is what our sea ice extent looks like in the Arctic. It oscillates between about 6 and 14 million square miles. So here is early in the year, so our winter time, sea ice extent is high. And then this is our fall over here, sea ice extent is low. And so we have this nice seasonal pattern. Okay, so what about plotting only the Antarctic sea ice extent? Well, one thing that's nice that we can do here is just copy this and modify the code instead of having to rewrite it. So instead of arcclim, we're going to do Antarctic clim, because remember the data is in the same format, so we just have to change the names here. This is going to be average Antarctic sea ice extent, and this should work. Let's see what we do. There we go, average Antarctic sea ice extent, and of course it looks like we oscillate between something like maybe 3 or 4 millions all the way up to maybe 15 or 20 million square kilometers. So a little more variation. And during our winter time, which is their summertime, they have low sea ice, and then they grow during the year. Just the opposite seasonal trend that we see before. So let's see what we can do now about plot both the Antarctic and Arctic sea ice extent. All right, so I'm just going to take my Antarctic code here, plotting code, and put it right here. I'm going to change, this is just average sea ice extent. Make that title a little generic. And let's see, what are we going to get here? We're going to get our Antarctic curve here again. And then what I'm going to do is add a function called points. And what points does is adds data to an existing plot. So in this case, we're going to add the Arctic data to this, and we already have that. So here is the Arctic data right here. So we're going to add our X is our Arctic climatology, column 1, which is our day of year, and then column 2, which is the extent, PCH 20. And Let's see what that looks like. All right, so we added another line here, but they're the same color. But that's okay. We can go ahead and come in here to our first one, Antarctic, and let's just specify col, which is our color, and we're just going to make it gray. And we'll go ahead and just specify the points too. Even though the default is black, we can just put it in there. Default black. And put that on there. Okay, so we have gray for Antarctica and black for Arctic. And the only thing we need to do now is add a legend so we know which curve is what. So there's a function called legend. And so you can take a look at this. Legend, you can add a legend to the plot. It's going to ask you where the X and Y are for this legend, what the legend is, and all these different arguments, but we're not going to go through all these. I'm just going to show you the ones you need for this particular one. So in this case, our X value is going to equal, let's just put the back button here back to our, back to plots. There they are. Is going to be bottom right. So that's going to stick our legend down in the bottom right portion of the graph. And our legend, we're going to concatenate two words together. It's going to be Arctic and Antarctic. And comma this, our point character that we're using equals 20. And our colors, let's just do this. Let's put a line weight in here. It's going to put a nice line on there. Line weight equals 2. Our color is going to equal, since we got our Arctic first, then our Antarctic, we know our Arctic is black. And our Antarctic is gray. So we put this in here, it should add a legend. Yeah, okay, so Arctic and Antarctic. And you see that we've got our point character, our line. We've got a box around it here that seems to be blocking part of the graph, but we can fix that. So let's come back over here, and we're going to put in a function called BTY. BTY is the box type. In this case, it's going to be no box type. And let's go ahead and run that again. Oh, we're running right over top of it, so let's go ahead and just run from line 26 again. So I got rid of our box type, but we still, don't like exactly where this is, so I'm going to add one more flag here. There's a function called horiz, or an option called horiz, and we're going to make that true. And that's going to make our graph or our legend horizontal. There. So there we go. There's the seasonal climatology for the Arctic and the Antarctic. You can go ahead and use export to save this somewhere. Export this, save it as an image or as a PDF. Let's do one last thing here, which is kind of fun, which is you can see that there's a seasonal climatology, right? It's high and low, and then low and high. And I wonder if they cancel each other out. I wonder if we could do that. So let's go ahead and grab our code here, our plotting code. Let's go ahead and plot the sum of the Arctic and Antarctic sea ice extent. So I wonder if they cancel each other out. So we'll go ahead and start with our Antarctic one here. What we can do in here is we know that this is our X, so this is our day of year. Here's Antarctic climatology. We're just going to go ahead and add arc clim 2, right? Because if we look at this, right, so let's look at the table. Here's Antarctic climatology. Here's the average extent, and click on this table. Here's the here's the Antarctic climatology. Here's the Arctic climatology. Again, in the second column, here's the first column. Here's the second column. We're just going to add those two numbers together. Let's go ahead and add those together and run the plot. Ah, interesting. So, let's change that back to black. Okay. A little easier to see. Oh, so they don't cancel each other out. So there are times of year where on average there is much more sea ice, just based on the seasonal cycles. And that is going to be around day 300. So that's going to be in late fall or early winter. In comparison to, early winter. And this is going to be late winter where we have the least amount of sea ice. And that varies by quite a bit, almost 10, I guess that's 8 million square miles and seasonal variability. Okay, so that brings us to the end of our lesson here, and I see that we still haven't saved anything here. We can click on the Save button, and you can go ahead and give this whatever name you want here. You can just call it Sea Ice Exercise, but you can give it your own name, and there we go.